Alright, Algebra 1, we're going to keep going with our solving and graphing inequalities here. In section 4.2, what we are going to do is called solving and graphing compound inequalities. So there's two different ways to do that, and we're going to cover that over the next few days. But first of all, let's review what we talked about in the previous notes in 4.1b. So here you go. You can see that we have some parentheses here which tells us that we have to use our distributive property. So what we will do is we'll take this -4. Don't forget that the negative goes with it. It's not just a 4. And we're going to multiply this through. So -4 times 3x and then -4 times -2. So that will give us, bring down the 6x, -4 times 3x is -12x. -4 times -2 is a +8. Is less than or equal to 20. Our next step, we will combine our like terms. So we got a 6x minus 12x. Okay, and remember when we're talking about combining like terms, we mean on the same side of the equal sign or the inequality sign. So 8 and 20 are not like terms. Well, they are like terms, but we don't combine them that way. We combine them by moving the 8 over, which we'll do later. So add these together. 6x minus 12x. That gives you a -6x. And then, like I had just got done saying, we will move the 8 over. Right here it's a +8, so remember we want to do the opposite and subtract 8. So we will subtract 8 from both sides. 8 minus 8 is 0, so these are gone. The left-hand side is just a -6x, and the right-hand side, 20 minus 8, gives us 12. And the last thing that we want to do here is we want to get rid of this -6, and we do that by dividing. Now remember, this is being multiplied, so we do the opposite and divide. I know some people look at that and say, well, shouldn't we be adding 6 because it's a -6? But that's not being subtracted from x, it's being multiplied by x. Okay, so that's why we do the opposite and divide. Now we should notice something else that just happened in this step, and that is we just flipped our inequality sign. Or I'm sorry, we just divided by a negative, so we need to flip our inequality sign, okay? So take note there, put a little star or draw an arrow like I did here. We just divided by a negative, which means we need to flip our inequality. So now we need to graph this. So like I said, what we're going to do is we're going to take our number, we're going to take the number that we just solved for, which is -2, and we're going to go ahead and put that in the middle, -2. One number greater than it on the right, less than it on the left. Since this has the line underneath it right here, that means it is a filled in circle. So we'll draw a circle and fill it in. Greater than means we're going to shade everything to the right. So that is your final answer there. Again, remember you have to have the number line filled in. That is how you display your answer. Okay, so compound inequalities, there are two different ways that compound inequalities are joined. Okay, the words that are used, we'll cover these in two separate sections of notes, but the words are and or. Okay, so the two words that are used to join together compound inequalities are and, which is what we're going to cover today, and then or is what we will cover on the 4.2b notes. Okay. So and inequality is what makes both of them true. Okay, like if you see something like x is greater than 1 and x is greater than 10, you know, we could think of some numbers that will fit both of these inequalities, like 3 or 6 or 9.2 or something like that, where if we had something like x is less than -10, now there's nothing that we could fit in here. X is greater than 1 and x is less than -10. So this is what we'll cover in the next day of notes, where this one would be filled in or joined with an or, because we could find one number that is either greater than 1 or it's less than -10. Okay, so that's how those two things are different, and you'll see them in the next between these notes, the 4.2a and 4.2b notes, we'll cover both of those topics. So let's go ahead and talk about some of these and statements. Now, you might see something like this that is not necessarily written with the word and. Let me jump ahead to example B. And you can see here that B clearly has the word and in between them. So, that's just one way of writing it. And typically and is written here when these numbers are different. Okay, if the number is, or I'm sorry, not those numbers. If these, let me back up. Not those numbers. If your expression, your algebraic expression, if these are different, then they'll be joined with the word and. But if both of those were the same, then you can see that this is how it will look. Now you could rewrite this. I'm going to show you this, but I'm not going to solve it this way. But you could rewrite this as -3 is less than 2x minus 1 and 2x minus 1 is less than or equal to 7. Like, you could rewrite it like that if you wanted to, and then you would just go through and solve each of them individually. But I just think that that's spending more time on the problem than you need to. And I'm going to show you the short way of doing this so that we can get these problems finished quicker. So, if you remember, when we're solving equations, our general goal, our general idea is we want to get that variable by itself. Okay, and that happens by doing two things in this problem. One is getting rid of the 2, and the other is getting rid of the -1. So remember, we do those in a certain order. So what we're going to do here is we're going to get rid of the 1 first. Okay, you always add or subtract the number that doesn't have a variable, and then divide by the number in front of the x. So we're going to get rid of this 1. So we're going to add 1. Now, where else do we add 1? Because we can't just add it right here. Okay, if this -3 wasn't here, we would just add it there and add it here. But since there are 3 parts to this, okay, this is 1 part, the middle here is 2 parts, and this part over here is the 3rd part. So there are 3 different parts to this inequality. Whatever we do here in the middle, we have to do it on the outsides as well. Okay, so we have to add 1 all across the board. Add 1 here, add 1 here, add 1 here. Okay, -1 plus 1 is 0. Those are gone. So my middle is 2x. And that x is a little sloppy. Let me rewrite it. X. There we go. Over here, -3 plus 1 is a -2. Let's bring down our inequality. Less than, is less than or equal to. 7 plus 1 is 8. Next, we need to get this x by itself again, so I need to get rid of this 2. It's being multiplied, right? That's being multiplied there, so do the opposite and divide. So we're going to divide every part of this by 2. Okay, there's 3 parts, divide each of those parts by 2. Now, the number in front of the x was positive. Okay, so we will not flip the signs. I know sometimes people will see this -2 up top here and say, well, that's a negative, I got to divide, or I have to flip the sign. That only happens when the number in front of the x is a negative, like this. If this was a -2 here, then we would do that, but since it's a positive 2, we don't flip signs. So -2 divided by 2 is -1, is less than, 2 divided by 2 is 1x, is less than or equal to, 8 divided by 2 is 4. Alright, so what does this look like on our number line now? Well, when we do these, we're going to put our smaller number on the left. So we're going to put a -1 over here. I'm not going to put any lines in between. Okay, I'm just going to put one on the left and one on the right, just like that. This inequality right here tells me that it's an open circle. So at -1, I put an open circle. And this inequality right here tells me it's a closed circle, so I'm going to put a filled in or a closed circle at 4. Okay, now for your shading, when you see the word and, or you see this compound inequality like we have here, we shade between our dots. So we're going to shade between the dots, and we're done. Alright, now for this one, we have this one separated as 2 inequalities, so this one we'll have to solve individually. So let's just start with this first one here. I'll do these in different colors. So I'm going to start with this first one here. Again, just like every problem, we have to get rid of the number with no variable first. So add 1 to both sides. Okay, now we're going to kind of separate this problem. All right, so this inequality over here, the negative 28 is less than or equal to 3x minus 1, has nothing to do with the 2x plus 7 is less than 19. So we're just going to, I'm drawing the line there just to separate them. It's not like these problems where you can work with them all together because they're all joined together into one string of inequalities. So let's keep that in mind. All right, so negative 28 plus 1 is a negative 27. Is less than or equal to negative 1 plus 1 is 0, so my right-hand side is just 3x. Now we will divide by 3 to get the x by itself, divide by 3, and we end up with a negative 9 is less than or equal to x. Which you could also rewrite this as x is greater than or equal to negative 9 if you choose, but we don't need to do that, and I'll show you why when we're finished. So let's come back up to this one. Move the 7. It's a positive 7, so I'm going to do the opposite and subtract 7. 7 minus 7 is 0, so my left-hand side is just 2x. It is less than 19 minus 7 is 12. Last step in this one, divide by 2, and we end up with 1x, or just x, is less than 6. All right, now, how do we represent this? Well, just like we did in the last one. I'm going to put the smaller number on the left, which is negative 9, bigger number on the right, which is 6. What kind of inequalities do we have? Well, this one is greater than or equal to, which means at negative 9, I'm going to put a filled-in circle. This is just a less than 6, so at 6, I will put an open circle and shade them in between. Alright, this one I have done for you. I would suggest that you go through and try it on your own, and then we can check your answer and see how you do. Alright, so the first thing that we need to do is distribute the 3 through. So 3 times n and 3 times negative 4. So bring down the 3 is less than or equal to, this is going to give us 3n minus 3 times 4 is 12 is less than 12. Next, we need to move this negative 12. So we move this by adding 12. And again, we're not just adding it once, we have to add it 3 times to the right and the left and the middle. Negative 12 plus 12 is 0. So those are gone. Alright, so we're getting closer to getting n by itself there in the middle. So I'm left with 3 plus 12 is 15, is less than or equal to, bring down to 3n, is less than 12 plus 12 is 24. So my next step to get n by itself, I have to divide by 3. So we're going to go through and we're going to divide everything by 3. Okay, remember you have to do that all 3 places. So 15 divided by 3 is 5. 3 divided by 3 is 1, so there's a 1n. We just don't write the 1. And 24 divided by 3 is 8. Alright, let's put this on our number line to get our final answer here. So again, even though these are pretty close together, I could put the 6 and 7 in between there. I could put 5 and then 6 and then 7 and then the 8. But it's not necessary. Okay, you don't have to do that. Alright, so less than or equal to means filled in circle here at 5, so fill that in. Just less than 8 means open circle at 8. It's an and, so I shade in between. Alright, last one. Again, same thing, pause the video and then check your work and see how you did. Alright, so here we go. Last problem. We're going to start off by moving this 1. So it's a positive 1, so that means I need to subtract 1 from all 3 places. So we subtract 1 here, subtract 1 here, subtract 1 here. So these two cancel out. 1 minus 1 is 0. They're gone. 7 minus 1 is 6. Bring down the negative 3x. 13 minus 1 is 12. Last step, to get x by itself, we need to divide by negative 3. everywhere, 6 divided by -3, -3 divided by -3, and 12 divided by -3. But what did we just notice? We just divided by a negative, so I'm going to make a little note to myself. These are going to flip, flip. So 6 divided by -3 is -2. Flip the inequality. Is greater than, or this is just is greater than. X is greater than 12 divided by -3 is -4. And you can leave it like that. I know some people like to put them in the correct order, so putting the smaller number on the left, bigger number on the right. You can do that, but this is perfectly acceptable to leave your answer like that also. And there's your number line. Smaller number on the left, and again, even this one you could put the -3 in the middle because it's only one number that's missing, but you don't have to. Bigger number on the right. These are both open circles, right? Because these are both less than, right? They're both is less than symbols, so they're both open circles, and you shade in between. All right, so again, like always, if you have any questions, send me a private comment or an email, and I will get back to you.